Hi everyone. In today's lesson, we are going to be looking at all the principles, rules, and laws in electronic configuration. These are the 5 core rules that govern how electrons fill orbitals. The first one is the Aufbau Principle, the Pauli Exclusion Principle, the Hund's Rule of Maximum Multiplicity. The fourth one is energy level order and sublevel order. The fifth one is the M plus L rule, which is also called the Madelung Rule. So we'll go through them one by one. First one is the Aufbau Principle, which is also called the building up principle. It says that electrons fill the lowest energy orbitals first before moving to the higher ones. In simple meaning, you fill the ground floor of a building before going to the first floor. For example, we have carbon with 6 electrons. It fills this way, the orbitals fill this way, from the 1s to the 2s, from the 2s to the 2p. This is 6 electrons. The 6 electrons. It doesn't feel like this. It doesn't feel from this to this. This is also 6 electrons, but it doesn't obey the Aufbau principle because it skips the 2s orbital. So this one obeys the Aufbau principle. This one does not. And of course, the 1s is lower in energy than the 2s. While the 2s is lower in energy than the 2p. This doesn't obey that rule. This moves directly from the 1s to the 2p by passing the 2s. So this is wrong. So this is what the Aufbau principle or the building up principle is all about. The next one is the Pauli exclusion principle. It says that no 2 electrons in the same atom can have the same 4 quantum number. Therefore, each orbital can hold a maximum of 2 electrons and they must have opposite spin. This is the orbital diagram. Each orbital can hold a maximum of 2 electrons. This is the orbital holding 2 electrons, and of course, then anti-parallel spins. Here we can also use carbon as another example. This is the 1s, this is the 2s, this is the 2p. This can hold a maximum of 2 electrons. This is 2s, maximum of 2 electrons. This is 1. This is 1. So the first one, 2 electrons, opposite spin. Second one, the same. So the 2p, 1, 1. Of course, we call this the 2px, the 2py, and the 2pz. We'll come to that later. So this is the orbital diagram of carbon, which obeys the Pauli exclusion principle. Next one is the Hund's Rule, which is also called the Pauli rule. It says that the electron fill the joint orbitals, which is the same as orbital with the same energy, like p, d, and f, by first filling each orbital singly first with parallel spin before the pair. We'll be using oxygen as an example here. Oxygen with 8 electrons. We're going to use it to illustrate this Hund's Rule. This is the orbital diagram of oxygen. That's 5 orbitals. This is the 1s. This is the 2s. These are the 2p orbitals, the x, y, and z. Each orbital will fill singly first with parallel spins. They have filled singly first with parallel spin, and then the pairing occurs. Then the pairing occurs with anti-parallel spins, which obey Pauli exclusion principle. So this is 8 electrons. That is also assuming that this is a neutral atom. So this is what Hund's Rule is all about. First, how electrons fill each orbital singly first, of course with parallel spin before pairing occurs. This is the fourth one, the energy level and sublevel order, which is also the orbital filling order. Of course, we said earlier that they fill in increasing energy, but there's an abnormality here, and here. If you notice, the 4s filled before the 3d, the 5s filled before the 4d, 6s before the 5d, and so on. Also happened here, 7s before the 6d. This is because the 4s is lower in energy than the 3d, the 5s is lower in energy than the 4d, 6s is lower in energy than the 5d, and so on. This order is based on what we call the Madelung Rule, which is called the N plus L rule. So this order, we call it the Madelung Rule, which is based on the N plus L rule, where this N is a principal quantum number, which is also the shell, and this is the sublevel. So which will bring us to the 5th rule. So in the last one, we noticed an abnormality, which we call the Madelung Rule. So we noticed in the last one that the 4s filled before the 3d, the 5s filled before the 4d. So this Madelung Rule states that electron fills orbital in the increasing order of n plus L, where the n is the principal quantum number of shell, the L is the sublevel, s equals to 0, p equals to 1, d equals to 2. So how do we calculate it? How do we use this rule? So we calculate the n plus L for each orbital. Here the lower value fills first. In the case where they are equal, the lower n fills first. In the case where they are equal, the lower shell will fill first. Let me explain. We notice that the 4s filled before the 3d. So using the Madelung Rule, here we say that s is equals to 0, p is equals to 1, d equals to 2, f is equals to 3. So here it will be 4 plus 0, which will give us 4. For the 3n, it will be 3 plus 2, according to this, the Madelung Rule, which will give us 5. So you can see that the 4 is lower than 5, which explains why the 4s is able to fill before the 3d. So this is all for today's class.